Hello and welcome back to our subject, Computer Organization and Architecture. Our topic for today is about computer level hierarchy. So you might be wondering how the computer performs or executes or operates if you want to, for example, make a document or play games. Okay, so figure 1.3 here is the abstract levels of modern computing systems. So if you notice that we have different levels from level 0 to level 6. And each level has or performs a particular operation. Okay, so I'll just give you a summary on how each level performs. No? For level 6, this is level under user or user level. This is where executable programs are run. Okay? So for example, Microsoft Word, Microsoft Excel, no, or games you want to play Dota, for example, it is in this particular level that we execute these particular application programs. Then we have level 5 or high level language. Okay, under the high level language is the softwares C++, Java, Fortran, and others. Now, we know that these high-level languages are being utilized to make executable programs, such as Microsoft Word and others. Okay? Then, we have level 4 is assembly language. So, assembly language, all of the high-level languages here are being translated into assembly language or low-level language, and it becomes or it uses the assembly code. In other words, the high-level languages here, once translated into assembly language, will have the so-called equivalent of assembly code. No? High-level languages, once passes through assembly language, it will create its own assembly code. Okay? And then this assembly code will now be used by the machine for the machine to understand the instruction. Then you have the level 3, which is your system software. In your system software, it is where your operating system or library code are executed. Okay? We know that the system software or operating system interprets or is used as an interpreter between the user and the hardware. Okay? Then we have level 2, which is your machine. Okay? It is where your instruction set architecture is executed. No? We know that when you say architecture, that deals with x86 architecture, okay, which is being used by AMD and Intel Corporation. So, in this particular area, instruction set are being executed. Then, you have level 1, which is control. It is where your control unit is located. So, some instructions coming from the instruction set architecture are being transmitted to your control unit for the control unit to perform or move a particular data from one area to another area of your computer. Okay? So, it is where your microcode or hardwired are located. Then, the last one, the level 0, is your digital logic. And we know, and everybody knows what is digital logic, no? It deals with AND gates, OR gates, and so on, right? And this digital logic are circuits or gates which are in the form of integrated circuit. Okay, so level 6, the user level, is composed of applications and is the level with which everyone is most familiar. At this level, we run programs such as word processor, graphics packages, or we play games. Okay? So this is where all your executable programs are being executed. All right? So for example, if you want to create a if you want to make an application letter, then we run the Microsoft Word processor. Okay? Or if you want to play Dota, then that is an application games. Then we have level 5, and that is the high level language. Consists of languages such as C, C++, Fortran, Pascal, Prolog, and others. These languages must be translated using either a compiler or an interpreter to a language the machine can understand. And what is this language? It is called the assembly language, which will be discussed in the next level. Okay? So, high level language, as we know, is used to create these so-called application softwares. Okay? Such as Microsoft Word and others. Okay. The next is level 4. Okay? Which is the assembly language level. The assembly language level encompasses some type of assembly language. It is a low-level programming language. As previously mentioned, compiled higher-level languages are first translated to assembly language, which is then directly translated to machine language. So from high-level language, it is converted into assembly language level, which creates the assembly code. And this assembly code will now be interpreted in by your machine, no? And we call it now as machine language. Okay, that is your level 4. Then for level 3, which is the system software level, deals with operating system instructions. This level is responsible for multi-programming, protecting memory, synchronizing processes, and various other important functions. It is the interface between the hardware and the user applications. Okay? So, one basic example of operating system is the Windows operating system, the Linux, and etc. Okay? So, your system software is the one that interprets or try to communicate, is the one that communicates the hardware into the application user, no? Which is kita, a user, no? So if you make, for example, a program and medyo nasayop ang imong paggama sa program, then the system software will provide you with an error message for you to be able to know that there is something wrong with your program. Okay, so it is the interpreter between the hardware and the user applications or the user itself. Okay, the next level is level 2. So level 2 is actually the machine level, wherein the instruction set architecture is being executed. Now, it consists of machine language recognized by the particular architecture of the computer system. An example of which is, again, your x86, which is being used by your AMD and Intel Corporation. Now, programs written in computers through machine language on a hardware computer can be executed directly by the electronic circuits without any interpreter, translator, or compiler. It is an interface between hardware and software. So basically, ISA is in between the software and the hardware. So whatever the software wants the hardware to do, it will pass through the ISA, no, for the hardware to perform a particular instruction provided by the software. Right? Now, for example, if you want to perform addition, which is found in your high-level language, na dito ang program to perform addition, for example, then this particular command in your high-level language will be converted into assembly code, wherein your machine will be able to understand this particular instruction. Okay? Now, this instruction through ISA will now be forwarded or will now be transmitted towards your hardware. And your instruction set, for example, the word add here, will now be executed by your processor. Okay? So that is how it works. Okay, so we go now to level 1. Level 1 is the control level or your control unit. Control unit makes sure that instructions are decoded and executed properly and that data is moved where and when it should be. The control unit interprets the machine instructions passed to it, one at a time, from the level above, that is your instruction set architecture, causing the required actions to take place. No? So for example, in our previous example, wherein your high-level language provides an addition program, no, it will be converted again into assembly code for the machine to understand. And then your ISA will provide the processor this particular instruction, and the processor under which is your arithmetic logic unit will perform addition. Okay? And this, the output of, after performing addition under your arithmetic logic unit, the data, the result, will be transmitted to another area of your computer. So, we make the ISA will provide instruction to your control unit to move this particular data into another area of your computer. All right? So it is the control unit that will transmit this particular data, the output of your arithmetic logic unit, to be transmitted or passed through another area of your computer. All right? Then, level 0, which is digital logic level. This is very common to us because we discussed this in our digital 1. Is where we find the physical components of the computer systems. The gates and wires. These are the fundamental building blocks. The implementations of mathematical logic that are common to all computer systems. So, digital logic level. For example, your ALU is composed of logic gates, right? Or and inverters and so on. And these logic gates performs mathematical or logical operations. Okay? And that is which can be found in your arithmetic or which can be found in your central processing unit. So in other words, digital logic level is in the form of integrated circuit, no? Because it says here physical components of the computer. Okay? So muna na siya katong ato ang ICs in your central processing unit, in your memories, and so on.